think we may start with spring seminars, that is CSE PhD seminars at our department. And today we have the first guest for our seminar, Dr. Farid Mehovic. He obtained his doctoral degree in computer science from UCLA. And then after the degree, he has pursuing data management, analytics career in various environments, including IBM, Sabre, HSBC, Facebook, that means different companies. His engagement has been hands-on and leadership in the domain of data science databases, as well as academic involvement in universities such as University of Dallas. He has been experienced in complexity around data platforms, causing delays, quality issues, and high cost in setting up, maintaining, and usage of data. He is currently focused on providing robust technology framework, substantially improving these situations with the databases. Okay, today's presentation is about data context solution. He is proposing for managing data platforms. Dr. Mehovic, welcome.
Thank you. They call you Med or Dr. Kantarjic?
Kantarjic.
Thank you very much.
Or Dr. K, I know that somebody
Dr.
is
K.
Yes. Sure.
I could be Dr. M if my name is difficult too. Thank you so much for attending. Good afternoon. I'm going to talk about, this is still an idea stage, but it is an approach to simplify managing data platforms. I have been in that space for a long time. I'm fully aware of many different challenges that come with it because of its complexity. So I'm going to say a little bit about databases versus platforms versus cloud platforms. What we used to have before the analytics really took off, we were worried about database and relational databases. With the data platform coming along to provide a place to do analytics, along with the database, we need to worry about a lot of tools that come with it. I'm just going to say that this typical, and a lot of it is happening in cloud. The cloud analytical databases that take probably about 90% of the market are from Amazon, Google, Microsoft, and then there's separate Snowflake and Databricks. As far as the cloud platforms, only the first three provide the full cloud platform solution with very complex ways to provide access and control access to the entire cloud platform. Just a little bit of background. I want to encourage you to ask any questions anytime, so please feel free. So what are those additional things that go along with the analytical database? ETL, you have to ingest the data, you have to transform it. Governance, you need to provide security, protection of data, data cataloging. That comes with governance. Insight is where you actually do analytics through various, using many different tools. Machine learning typically is really part of this insight section, but it has such an importance that I've taken it out as a separate item. And delivery, how you deliver the insights, the data, whether it's via visualization of different kinds, dashboards, and so on. One key aspect of the quality of a data platform, how good it is how quickly you can derive at insight. That's what we call time to insight. So if your platform, if you can find your analytical answers to questions, to business problems and market problems, if you could find that more quickly, You're ahead of others. You can move your company more quickly. You can be saving money or saving the company from going under. So this time to insight is the key metric. There are others like the expense, all of that, but the biggest one is time to insight. To address time to insight, working with platforms, setting it up, using it, maintaining it, needs to be as simple and as straightforward as possible. Whether you're integrating it, bringing new tools onto the platform, whether you are making some changes, whether you're actually doing analytics, do you need to worry about many different tools at the same time? You have to switch context, go to another tool, or engage a lot more experts to do that. All of that comes into play when we talk about affecting time to insight. So one key aspect then would be to have as simple as possible way to integrate and maintain and use the platform. Now I'm going to talk about two different examples. Dr. K wanted me to start with some examples to really illustrate the complexity of today's approach to a couple of these different aspects of the platform. So one of them is ETL. This slide only shows how important ETL is, how much it is used, and it's displaying here the market value of that, how much of this, how much money is involved here. And by the year 2032, we talk about $20 billion market. Obviously, it is important. And here's an example. So I spent a lot of time writing ETL solutions, ETL programs, leading teams to do that. This seems like a complicated description. What I did to illustrate how this would be done now and how it could be done with a data context approach. I've submitted this question to ChatGPT, and ChatGPT gave me this code. Now, this code I couldn't just take and run. I'm sure there would be things that I would need to address, but it does a very good job of providing a lot of information to guide you to actually go in there and edit it and make it work. Still, this is Python. This is using Airflow. Airflow, I think it is used in about 2/3 of the ETL work today in the United States, I think. So it's used quite a bit. There's a DBT. I have an example how ChatGPT would do it in DBT. But this is very, very common in Airflow. This is 139 lines of code. We have 2 languages. I mean, it's all Python, but embedded in Python is SQL and generation of SQL. So there's one of these methods in Python is generating an SQL command, which I don't really favor that, because then you lose the visibility of what the SQL command is because you're generating it. Anyway, so this is ChatGPT. And this is what would be the solution if we were making certain changes to SQL, certain extensions to SQL. What ETL, what Airflow is used for is it allows you to orchestrate the ETL process, the DAG. It allows you to parallelize work. And it allows you to define dependencies. This part of execution depends on that, and so on. So those are 3 things that all of which are being actually used by adding a few of these keywords that are in orange or brown. So if you want to submit something, normally SQL will not allow you to do that. If you use any tool, it will execute SQL sequentially if you go to SQL Canvas in any of these tools, Redshift, Snowflake, and so on. But why not say submit? You can give it a name, and you're running that, and the execution proceeds to the next command. Why wait? That is parallelization and orchestration. Below here, so you have submit, and then there's a file command, which might even be optional, but this is a way to, without any other setup, you go to an S3 bucket where there's a file and you're selecting from the file. Just a simplified way of doing that. We do that to load customer data. We do that to load user data. And we are saying, do a modification on the user data after it has loaded. So we have the command submit, again, in background. After this method is finished, and it's saying, at that time, do the command of updating a new column. So we didn't go through creating a new column. We just said this column is new. And then we're just waiting for everything to finish. We're actually specifying what needs to finish. What we did, we just took SQL that's already powerful. We just added a few keywords. And we would not, for the most part, maybe 80–90% of these Airflow jobs, from my experience, just one sec, at Facebook, like 80% of the code is SQL, and these three things that I mentioned are the only reason we did that. Go ahead.
Is there a way to add some kind of data validation to that? So like, say, for example, you get a file in from like another company or from a user. Would there be a way for you to have some kind of SQL that does data validation to ensure it's matching whatever your requirements are before just shoving it in?
Well, obviously, you would need to code that. We might find a way to simplify that as well, to compare. One thing that we did here, we on the fly added these columns and said that this field, number 4 from the file, we want to enforce uniqueness. So we're saying it's primary key. So this whole thing is going to fail if that is not true. We also on the fly added a date which could be passed as a parameter here. This is very typical. At Facebook, we had daily versions of every possible data that we have. And so this was a very, very common field that we used quite a bit. Any other question? Okay, so it's simpler. Because it's simpler, it's easier to understand, it's easier to maintain, it's easier to change, to understand, and so on. And it's quicker to write. Here's another example. Not an expert in machine learning, but I would like to become. We all know that now it is very, very popular and used quite a bit. The value in the market is even much higher. So we're talking about in 2030, $60 billion. And this, I think, is just United States. So it's important. This is a small example. So I'm going to talk about this a little bit more, but machine learning is working and building a machine learning process, machine learning model, and all of that is a process that we aim to simplify. This request is the only thing it's doing is creating a machine learning model in a specific tool that we want to use. We want to use Sagemaker, which AWS uses. ChatGPT created this code. You need to use Sagemaker SDK, Software Development Kit. And if we were doing this in data context, it would be an 8 lines of code little program, which is SQL. The only thing it does is, it's like creating a table, but you're creating a model. That's all it is. In fact, Redshift has this command very similar, but this command does not exist in other databases. If you wanted to use Snowflake as your data platform with Sagemaker, you cannot do that. Now, Snowflake has its own create model command that uses its own machine learning library, but it is not a good quality. It's not very robust. So you would ideally want to use Snowflake with Sagemaker. And data context would allow you to, within hours, actually create a new command that would look like this, but it would be in Snowflake.
Are these processes run, are these processes run on something that's kind of dedicated? Once they start, they're guaranteed to finish. It isn't like one of these things where you have instances where like they may go into hibernation as a hypervisor and then pick back up. Is that correct?
I need to hear that again, sorry.
On AWS, so you're familiar with sometimes you can suspend some processes into like a hibernation mode. When these services run, as kind of complex as they are they pretty dedicated when they start? They actually complete with that max runtime?
We are not really that level. I mean, whatever would be preferable, we would try to do then. It's just an idea stage. We did do a little prototype. We were able to create model command in Postgres that would go to Sagemaker. Very limited, but actually happened. All we need to do is we need to create this command and define what it needs to do, which is basically a few API calls, not much. So the actual challenge in using and creating new commands isn't as huge. So it's really, I mean, it would make a lot of sense to try to implement this. Yes?
Is there a way to add like resource limitations to it, like when you're creating the command so that it can't use like past a certain amount of resources, or it has like a max limit, or does that have to be set within the database itself?
Well, we would want to put it at the optimal place. If you're talking about limiting training a model, that is already a part of the command, run maximum runtime. If you wanted to limit any SQL command, we could go back here and just say here, up to or limit time, add another keyword and add that, and we could, I'm sure there's a way to actually ask the database, the underlying database, to limit that. So yes, and that would make it simple. I think that's a good idea. I haven't thought of that one, but why not? Any other questions? So those are two examples where we looked at ETL, just one of the areas of data platform, the complex data platform, and we looked at a machine learning create model. Now, this is actually the potential scope of this entire project is huge. As you saw, there are many different areas of the data platform that we could address: governance, cataloging, ETL was one, machine learning, and so on. So that's one huge area. Then you have integration with many, many different types of tools. We would pick the most interesting, the most popular tools. Sagemaker is one of them. It's very powerful. TensorFlow is another one machine learning tool that we would like to be able to integrate and so on. But there's a variety. For ETL, Airflow was one. dbt is another one that's become pretty popular. I wanted to point out that we are not trying to redo what these tools are doing. Well, these tools still would remain on the platform. All we're trying to do is simplify working with them. Ideally, you don't have to go to Sagemaker to do something there before you can create your models and so on. So you don't need to be switching context. And the name of this project, Data Context, is really the idea that you don't want to be switching context. We know it's a problem anyway, just human mind is harder to deal with, but it's lengthy, it's costly. You need experts in all of these tools. You still may need them, but way less. For example, if we were to implement that ETL example, we could in the background generate Airflow Python code. That is an exact generation that would always be working well. You just execute a command, Airflow gets, Python code gets generated and gets executed. All right, I'm going to talk about, I have 2 slides that are looking at a little bit broader picture. So the first one could be some examples of projects. Now, because this is so wide, there's so much that could be done in different areas. I would start with one of them would be very technical and very hands-on, and would be how to define an optimal architecture to implement data context. It could be a totally separate application that needs to somehow integrate with all of these tools and your core base data platform or your analytical database. It could be a layer that is on top of the database, like a pre-compiler that can understand the new commands you created and then executes them. And if it's not one of those commands, it will basically send the command down through to the underlying data platform, analytics database. To define what this technical stack is, build a working prototype. It could be very limited, but enough to visualize and understand and prove the value of the architecture. So that's, to me, sounds very fun. Language extensibility. So for us to create these new commands, examples of which I showed, that means we need to have a way to create them on the fly in SQL without having to go through some long development cycles to do that. As you saw, create model exists in at least 2 analytical databases. But how do they do it? This new command, it's not part of the regular, so far, SQL, create model. They basically developed it, they put it on their roadmap, they've developed it, it took 6 months, a year, and the integration with Sagemaker was made. I'm talking about AWS Redshift. What we want to do is allow you to do that in hours, in 1 or 2 hours. That means we need 2 key commands. Could be just one, but we know that an object that gets created, like model, would require multiple commands to manage it, to create it, update it, drop it, whatever. So it makes sense to have a create object command. So basically in SQL, you would go and you would say create object model, and you would define all various parameters that are pertinent for a machine learning model. As soon as you do that, we have structures created in the database that support the model. And right after that, you would be able to visualize any models that you later create on your GUI interface, or you could list it through SQL, show me the models, and so on. The other is to create a command. So you can create command train that does something with that model. Validate. Maybe some various commands around discovering data, understanding, verifying that it's valid to be used, and so on. So these 2 commands, create object and create model, would be it. What that constitutes is an ability to extend SQL language, not in a traditional way. What we call relational database extensions are user-defined functions, user-defined types, procedures, even triggers. All of those things contain logic. This would be, from the syntax perspective, relatively similar. All we're doing is saying, create command to create a model, and then we specify in code, just like you would do for user-defined function, what needs to be done. And you can use Python for that, as you can now in stored procedures and in user-defined functions. You define that, and you're done. You can test it and so on, but then within hours or a day or two, let's say, you have integrated commands, you have integrated Sagemaker, you've created a few commands, and you have it. And the way you would use it is what I showed you. It's an 8 or whatever 9-line SQL command to create a model or to train a model. An important part of this language extensibility item is what kind of, beyond just creating these commands, what methodology do we want to use to select the best optimal set of new objects and new commands to make it very usable, very easy to understand. So that we talk about methodology. So what is the methodology of extending SQL for a certain field, for a certain area? And that means we need to understand that area really well. We need to understand what the process of machine learning is. What does it take? What does it take to do data discovery? What does it take to do data preparation, and so on? And based on that, we want to select the minimum number of tools, objects and commands, sorry, to extend the language to become very, very usable in that area, which would result in us not having to go to this other tool too much and stay within the same data context, which is typically we spend most of the time when you work with data, which is the data platform, analytical platform. So these last two really are implementations of those two examples I mentioned. Enhanced ETL, could we build a minimum product, version 0, version 1, where we actually implement those, that we add those keywords that you saw, 5 or 6, and we can actually code ETL without leaving SQL. And the other is the machine learning. So this is what I mentioned. Understanding the process, creating types of objects that are key, not hundreds, but maybe 2 or 3 or 4, and commands that go with it. Questions? All right, so when I look at the entirety of this idea, it could have very wide implications here. So the very core layer is what I mentioned, the ability to extend the language. This is not creating anything yet, but you have the ability to create a new object and to create new commands that typically work with those objects. I will say that these objects are still implemented in relational database through tables, through information schema, the metadata of the database. One very important aspect of relational technology that all the data is in one structure, which is stable. That is very important. So we're not saying we are complicating the implementation of data in the database. All we're saying when we're creating objects, we're saying this type of table, this type of object is so important that we want to bring it into terminology of the language. So if you're dealing with model, you may want to be saying, do this with model, do that with model, as opposed to, let me update this table and that table. So it's simplification, and it is also making it easier to understand. and closer to others. People that work maybe not very technical, but they know what the model is. They don't have to go down below that to see what you're doing with the model. Technology verticals is some of the things I already talked about. So those different separate areas of different tooling and things that you need to do beyond the database on the data analytical data platform, those are, I call those technology verticals, ML being one of those, ETL another, governance another, and so on. So for each one of those, understand what is done there, look at examples, understand terminology, select the right set of objects and commands, and extend SQL to do that. And extending SQL, because we have number one here, is also easy. So the biggest part is making it very, very usable and understanding the underlying processes that you're trying to simplify. Industry verticals is another one. Why not go to a business layer? So you have an insurance industry. What are the key objects in the insurance industry? You have claims, you have patients or clients, and so on. Why wouldn't they become objects? And instead of writing SQL to work with some tables, you actually say, create me a claim, or do this with claim, verify claim, validate, and so on. That way, when you're writing applications in a specific industry, your application code becomes simpler, and you do a lot more in the database so that you don't have to worry about when you write application. And finally, I mean, you can create objects, you can create commands. What does that remind you of? The object-oriented programming, you create objects and methods. You create objects and commands. So you could, right, go to the extreme and create an application where you code very, very little in the third generation programming languages, Python and whatever, but you have just about everything defined in the database through objects and commands on it. Obviously, this is really an approach of database-centric development. This will be ultra database-centric development. But it does provide simplification. Database is also providing a way to be much more rigorous with data integrity and so on. That's the future, potentially. Questions?
Okay. Do we have questions? Please, let's go. Oh, just a moment. Okay.
It seems to me that the motivation seems like it's almost trying to make it easier for like a company to create these systems, because in Azure and AWS, some of these things become quite complicated, just creating the links between these things as well, correct? How much money do you think will be saved if you're successful in making this mainstream for like the expense of the developer time?
Well, the biggest money saving wouldn't be in resources or reduction of experts that you need to pay. It would be in sped up time to insight. Because, an example, if you make a decision, let's say in Facebook, let's say, that resulted in 2% increased profitability. And I don't know what the revenue of Facebook right now is. Let's say it's $1 billion, whatever. If you do it in 8 months, you will be waiting 8 months to start capitalizing on that. If you do it in 2 weeks, then you have made half a billion. That is a lot of money. If you are a small company and you're very slow, you may just go out of business because you weren't able to quickly do some analytics and make some decisions. I can't give you figures. I think experts. We can come up with some numbers, but if you could reduce, I think, the cost of experts by, let's say, 80%, and if you have 10 experts, if that means a few $1 million a year. Overall, that's not as big an issue, but it's still saving. It's still a big saving. But in addition to that, we are talking about quality. So if you're generating something explicitly, as this would do, you generate Airflow code, you generate calls to Sagemaker. They're working. It's not, you can have errors, manual errors by people. So that also is a big factor. Quality, speed, and money.
So to clarify, the purpose is more for speeding up development time than anything else?
Speeding up development is one. Speeding up usage, well, I guess you do development when you build these new analytical, try to find analytical solutions. Yes, it's faster development, it's faster integration, faster maintenance, and faster development.
I got one over here. So you think using this Bison API, just extending the language and doing all your operations inside of a database instead of just like doing an API call, this would be more efficient from a development perspective? Because I get it. It's like you're extending the language, but like, is the juice worth the squeeze? There's always like an opportunity cost trade-off. But if you were, like, if you go back to like, your DC project slide, there's one that really stuck out to me. It was the second one.
ML example? This one? Or this one?
Go to DC projects, down to
this one?
5 slides down. No. Keep going. Keep going. Keep going. All right. So like the extensibility thing. So I'm trying to think about this like from a business perspective. Couldn't you just like have a service that like businesses could use that does this instead of giving them the keys to the kingdom?
Well, you are executing the service, but where would you do it?
That's my question to you.
Well, you would be doing it in a different context.
Yeah.
And the thing here is, we don't want to be going to a different context. I want it right here, where I do 80% of my work anyway. Doing the same thing, it's just integrated into language that is, SQL is English-like. It's not perfect by any means, but easy to understand, and that's where you do other things as well. The context, yeah. Single context. It will never be totally single context, but it would be a big improvement potentially.
It is on the level of conceptual level, like
Yes.
the entire idea. But here we have students, young students, a little bit more experienced students. If they want to go in this direction, okay, not everybody will go in direction to develop the entire system, data context system, but they would like to work in a domain. Is there any suggestion? What are critical points? What are the initial idea would be some kind of suggestion in a given domain? So if we have one master student and he or she wants to make master project in this domain or thesis, what would be direction? What would be recommendation?
All right, who knows who this guy is? Nobody? There were some students when I was putting this picture up, not even that. You can cheat. This is Michael Stonebreaker. Does that name ring a bell? Have you guys programmed in Postgres? Do you know what it is? 1, 2, 3. Postgres is not only the best quality open source database system, but it is the basis on which many, many other databases are built, including Redshift that I mentioned. It's a very, very powerful database. He won a Turing Award a few years ago. He's really one of the top scientists. He's done a lot of research. You can Google him. You can look him up on Wiki. He's built many different startups, basically working with students to develop ideas and then promote them.
And one of the most important or most well-known book in databases.
Yes, like in data, that's his field. So he's done a lot of research, and he's done a lot of implementation of that in industry. I talked to him in a few months ago, August, I think, and he really encouraged focusing on this one technical area, technology vertical, which is machine learning simplification. He thinks, and I think many other people think, that is very cumbersome. It requires a lot of work, that is not very streamlined. 80–90% of the work on machine learning models is actually very heavy with data, all those steps I mentioned. Discovery, validation, is this data good, why not, preparation, and so on. So because of that, I would say that this streamlined ML, whatever component of this area we take, would be tremendously valuable. So as part of this ML process is also MLOps. They do a lot of work as well to support that, make it easier. So this would require 2 steps. One, to look at the process. You can actually go to ChatGPT. I have it in one of these files. It will explain to you the process and how much of that process, what percentage of time it takes to be doing those various steps in developing excuse me, machine learning model. So it is very complex and challenging. That could be and should be simplified. So it is not trivial, but it would have a tremendous impact. Another one may be excuse me, enhancing ETL with these few little additional keywords to simplify ETL. I mentioned dbt. This is ChatGPT's solution using dbt. It is simpler than Airflow, but it doesn't do everything. dbt is there for transformation, not so much for ingestion. dbt wants to say that you can do ETL and you only use SQL. Is this only SQL? I don't think so. There's a lot of these keywords that you need to worry about and worry about another context to work with it. So what I think we could do is we could do Airflow better than Airflow, and we could do dbt better than dbt. And if we do that, that would be tremendous. Because dbt is very popular, but if you could do it without, I mean, even a lot faster and better quality, that would be a really great progress. Other areas you can pick. If you like data cataloging, if you like data quality, we can go into governance. And so there are, if you're interested in specific topics that you know being used in a data platform, you can focus on that. The other thing is more, I would say, philosophical. If you talk about language extensibility, you can do some survey research of current database SQL syntax and what they offer and why. You will find that Snowflake is pretty heavy on adding objects to work with ETL, to go to, not in the way I'm saying, it's more complicated, but you work with a bucket, I think, is a separate object, some other layers of access, they have too many. I don't think it's as elegant as it could be. And has a little bit of machine learning additions, like grade model. Redshift does not have that as much, the ETL stuff, but it does have more on machine learning. What are they doing now? Why isn't there what we are talking about already there? What does standard SQL provide now, and what are they planning? Is grade model already part of standard SQL or not? Why not? That kind of thing. How much basically validate what we're trying to do here from a deep research perspective, looking at what's there and developing the methodology of adding new. So those are all things that you could think about and research and see why and why not. And that research could be also based on the test bed of doing these other projects with actual coding, right?
Thank you. Do we have any
Can I
additional questions?
May I ask just a career advice? So we have some students in here that are probably on their path to a career in industry. It sounds like you are a very heavy AWS person, it sounds like, I would say. Would you what would be a certification you'd recommend to students? Solutions architect, DevOps, would you recommend these certifications in these cloud platforms?
What I suggest to my son, who doesn't listen to me,
Right.
and anybody who likes math and is good in math, is to go into data science. I think it's a topic that, it's a calling that is needed more and more. There's only more and more demand, and it's paid better and better. Yes?
Are there other specializations like data science that you would recommend, like machine learning or AI? Since
Absolutely.
those fields are expected to increase in value.
Right. I mean, data science sort of could include that, but yes, definitely. Machine learning engineer, I think, is a very important skill now, for sure. AI is big. When you talk about startups, we talk about the multiplication factor, meaning you're making an X amount of money a year now. What is the company worth? The multiplication factor for AI-related startups is 30. So if you're making 100,000, that means 3 billion valuation. Normally, software is around 10, a little more, and then other things that are not technical could be just one. Like you have something in transportation, they make a billion, they're worth $1 billion. So it is the highest factor that is out there right now.
So is this going to have an impact or implication in the autonomous driving?
Haven't thought about it. I don't know. Seems to be very real-time oriented, maybe on the analytics. I guess autonomous driving does rely on machine learning models that are built, pre-built.
Yeah.
So yes, I mean, in the background, you would want to have processes that are faster to leverage the machine learning models, to maintain them, to build them, and so on.
Okay, one more information note, which is maybe not too much connected to, with today's presentation, about a little bit relation Dr. Mehovic and I have. He was my student a long time ago in Europe, and he was a student. I don't know, we discussed today, I think it was the first year at
First year.
study. And during the first year, he worked on one paper, and he published the paper, and that was one of the first paper I'm sure he made, because that he was at or at your level. That means first or second year.
First year.
First or second year. And he made the publishing of the paper. and it's interesting to just he reminds me. It was about some kind of data analytics, about some data, processing the data at that time with the computers we had at that time. But that means for all of you in this domain, including you have a chance to start now. That means even if you are first year, junior or something like that, yes, it is a time even for publication of the papers. Because I've seen there are some students in this domain, it is not only the classes, open the door, your ideas, and try to make, include in this research domain as soon as possible. Okay, do we have any additional question about today's presentation? If not, I would like to thank one more time
Thank you.